Okay, so we're going to do polar graphs part 2. So in this graph, we're going to learn how to put all the information we learned in the last couple of sections together and actually graph some polar functions. So the best way to do this is by example. Now remember, the few things you're going to look for is you're going to identify the type of polar graph it is, the type of symmetry. Now remember, if it's with, here are our tests for whichever type of symmetry we're looking for. Our maximum value of R, the zeros of the function, and we're going to look at developing a table and how to kind of strategize what table of values to use and to sketch the graph. So starting with our first example, I'm given that r squared is equal to 4 sine of 2 theta. So from my knowledge, I know that this is a limit. I also recall that it's a sine function, and our a squared term, which is the 4 in this case, is positive. So the limit is going to be diagonal in this positive direction. So looking at this, how I expect this graph could look at, I can figure out that I pretty much expect to have symmetry about the pole. So that's the one I'm going to test for. So I'm going to show my work on testing for symmetry about the pole. So that's where I replace the r with negative r and theta with theta. And I do get the original function or equivalent to the original function back. So yes, this is symmetric with respect to the pole. Then I'm going to look for a maximum value of r, and that's just simply replacing the sine of 2 theta with 1, and I'll get 4 as my answer. Or r squared is equal to 4, so r is equal to 2. So my maximum value of r is 2. Then the zeros, I just set r equal to 0. So I get 0 is equal to 4 sine of 2 theta, or 0 is equal to sine of 2 theta. So I ask myself what angles has a sine equal to 0. And the angles that have a sine equal to 0 on our unit circle would be 0 plus n pi. And so theta, when I divide everything by 2, would be 0 plus n pi over 2. Now for graphing purposes, we usually just want to list our zeros in one rotation around the unit circle. In some cases you might have to go farther, but that's where we'll start with. And so my zeros are 0, pi over 2, pi, and 3 pi over 2. Now to figure out my table of values, I'm going to, hopefully my symmetry will help me. So I'm only going to go from one 0 to the next 0. So I'm going to start as theta equals 0. And then I'll put in some major points on the unit circle up until I get to the next 0, which is pi over 2. So I'm just doing my first quadrant here, the unit circle. All right, so I already know that 0 plugged substitute into the function gives me 0, and pi over 2 substituting function gives me a radius of 0, because that was we found earlier. And then plugging in pi over 6, pi over 4, and pi over 3, I get the following answers into that function. I just rounded one decimal place because that's as exact as I can get on the graph. Now I'm going to plot these points. So 0, 0, and then at a radius of 1.9 with an angle of 30 degrees, or pi over 6. And then a negative radius with the same angle puts us on this side. And then pi over 4. We have a slope, a radius of 2 and negative 2. At pi over 3, we have radius of 1.9 and negative 1.9. And then back at pi over 2, we're back to 0. So as you can see, that is that shape I expected that I had memorized earlier from our last section. So you have graphed your first polar graph. Okay, now I want you to try this one. R is equal to 2 cosine of 2 theta. Okay, first thing you need to do is recognize that this is a rose curve, and also because the n is 2 an even number, we have 4 petals. We are cosine, so, and it's even, so we know to expect a shape like the following. And so therefore I expect this one to have all three symmetries. So I expect it to be symmetric, expect to the line of theta is equal to pi over 2, the polar axis, and the pole. So I'm going to have to work all 3 tests out in this example. To test if it's symmetric with respect to the line theta is equal to pi over 2. Okay, so first, before we can substitute in that pi minus theta, I need to rewrite cosine of 2 theta using my double angle formula. And so I'm going to choose to use 1 minus 2 sine squared theta. You're going to choose any of the double angle formulas for cosine. And now for testing for if it's symmetric with respect to the line theta equals pi over 2, I'm going to replace every theta with pi minus theta and simplify down using my difference formula. And we end up with the exact same equation as we started with. So that, yes, we prove symmetry with respect to theta is equal to pi over 2 line. Now for the polar axis, I'm going to test and see r and negative theta. So replace everything in negative theta. Remember the sign of negative theta is odd function, so it's negative sine of theta, but when I square that, it becomes positive, so the equation does not change. And then to test with the pole, because it's kind of hard to see if I test with the negative r theta, I'm going to use the other equation, and I'm going to test with r comma theta plus, pi plus theta. Doing my difference formulas here and simplifying down, I end up with equation equivalent or equal to our original function. So yes, it's symmetry with respect to the pole. So we have symmetry all 3 directions. Okay, next I'm going to figure out my maximum value of r. To find my maximum value of r, I'm just going to replace cosine of 2 theta with 1, and I end up with 2. So the maximum radius is 2. Now I need to find my zeros. So I set my equation equal to 0. Dividing by 2 gives us 0 is equal to cosine of 2 theta. So an angle whose cosine is equal to 0, and that would be pi over 2 plus n pi. Dividing everything by 2, I get theta is equal to pi over 4 plus n pi over 2. Now I'm going to find our answers in the first, from the unit circle. And so when I work through that, kind of help me work through, I'm going to rewrite this as theta over 4 plus 2n pi over 4. And so when I replace n with 0, I get pi over 4. When I replace n with 1, I get 3 pi over 4. When I replace n with 2, I get 5 pi over 4. And n with 3, I get 7 pi over 4. And that is as far as I need to go. Okay, now I need to develop a table of values. I'm going to go from 1, 0 to the next 0, and hopefully my symmetry will allow me to figure out the rest of it. So I'm going to start at pi over 4 and go up to 3 pi over 4, just using some special angles in my unit circle. Okay, replacing every theta with pi over 4, and using my calculator to help me. I already know that pi over 4 is equal to 0. Pi over 3, when I plug that in, I get a negative 1. Pi over 2 is negative 2. And 4 pi over 3 is negative 1. So I'm going to plot these 5 points on my polar coordinate system. So 0 pi over 4 is equal to a dot here at the pole. And then negative 1 pi over 3. And then a negative 2 pi over 2, negative 1, 4 pi over 3, and 0. Oh, that dot's off. And that gives me one of my 4 petals. And so since it's symmetric with respect to the line theta is equal to pi over 2, I know these 3 dots are also there. So that gives me another petal. And then since this is symmetric with respect to the pole, I know that these 4 dots exist. Now since it's symmetric with respect to the polar axis, I can do this side as well. Okay, for our next example, we have 4 sine, r is equal to 4 sine theta. The first thing you have to do is recognize the type of function that this is, the type of polar equation this is, which is a circle. And since it's sine, it's with the y, 4 is positive, it's the diameter is along the line, theta is equal to pi over 2, the positive y-axis. And so since it's on that, I will expect to have symmetry with respect to the line, theta is equal to pi over 2. So that's what I'm going to test for. by replacing every r with r and theta with r minus theta. And yes, it's symmetric with respect to the line. Theta is equal to pi over 2. Now I need to find my maximum value of r by replacing sine of theta with 1, and I get my maximum value of r is 4. Now I'm going to find my zeros of my polar graph by replacing r with 0 and solving for r theta, and I end up that sine of theta is equal to 0, and where in the unit circle is sine of theta equals 0, at least from 0 to 2 pi, and that's at 0 and pi. So I'm going to make a table of values for part E, starting at 0 and going up. Well, I could go up to pi, but because of that symmetry with that respect to the line pi over 2, I'm going to go all the way up to pi over 2. And then I maybe can use my symmetry to graph the rest. So I'm going to just use 0, pi over 6, pi over 4, pi over 3, and pi over 2. Okay, so I already know that 0 is 0. And so when I replace pi with pi over 6, I get 2, and then 2.8, 3.5, and 4. Again, I'm using my calculator to help me with this. So I'm going to plot these points. So 0, 0, 2, pi over 6, 2.8, pi over 4, 3.5, pi over 3, and pi over 2, I'm at 4. Now I'm going to use the symmetry with respect to that line of theta is equal to pi over 2 to plot the left-hand side of the circle. And now I have my graph. Okay, your turn. Try r is equal to 2 minus 3 cosine theta. So I know this is a limicon, and I need to figure out which of the 4 types it is by doing the ratio of 2 divided by 3, which gives us something less than 1. So this is an inner loop limicon. Okay, so since I have cosine and I have a negative in between, I expect it to be on the negative x-axis or the negative polar axis. So I expect it to look something like this. So looking at that graph, it looks like I should expect symmetry with respect to the polar axis. So that's the one I will test for. Okay, I would test for the symmetry with respect to polar axis by replacing r with r and theta with negative theta. And since cosine is an even function, I end up with the original equation. So yes, it is symmetric with respect to the polar axis. Next, I'm going to find my maximum value of r by replacing cosine of theta with negative 1 in this case, which gives me a maximum value, or maximum radius of 5. Then we're going to find our zeros by replacing r with 0 and solving. And I end up that cosine of theta is equal to 2/3. So I will have to use my graphing calculator to figure this one out. So I'm going to do the inverse of 2/3 and figure out what that is. Using my calculator, I get theta is approximately 0.84 radians. Now a little trial and error with my pi over 4, pi over 3, and I find out that that's in between pi over 4, and pi over 3. So I'm going to start my table at pi over 4, and then my next one would only be in quadrant 4, so my next 0 in my unit circle is going to be at 5.44 radians. So I need to go, my table values needs to go from 0.84 radians to 5.44 radians. I might be able to stop earlier if I can see a pattern for the reflection, but I'm pretty sure I'm going to go to about 5. So I'm going to set up my table of values starting at pi over 4, which is a little bit less than that 0.84 radians. And then go to little past 5 pi over 4. Okay, so now I'm going to plot all these points that we found so far. I know in between these two dots I do go to 0 at that 0.84 radians. I know I have a dot at 0, so I'm going to go through the 0. And then pi is at 5 radians. And now I'm going to stop because now I can do symmetry of the polar axis to figure out my other side. So I'm just going to flip these over that polar axis. All the points I got plotted so far. And now I'm going to connect these dots, drawing that inner loop limicon shape. Okay, now let's find the r is equal to 3 secant theta. All right, so first I'm going to rewrite this as r is equal to 3 cosine of theta, and I need to recognize that this is a vertical line. So I don't have to do a lot of the things will not apply in this case because I know there's a vertical line. Remember that distance is a, so I know I'm a distance from 3, so I can sketch this graph really fast right now. There's my graph. Okay, now to fill in a few of the blanks in a few of the data, I can look at this graph and see that it's going to be symmetric with respect to the polar axis, so that's the one I need a test for. Remember, to test symmetry with respect to polar axis, I can replace r with r and theta with negative theta. And I end up that r is equal to 3 over cosine of theta, or r is equal to 3 secant theta. So yes, it's symmetric with respect to the polar axis.